Hi guys. So what we're going to be talking about today is we're going to be looking at adding and subtracting fractions with an unlike denominator. So an unlike denominator is the bottom number. If it's not the exact same number, we can't compare them yet. We have to convert it so that they have the same size pieces. So to do that, there's two different ways that we can do it. You can either find a least common multiple or just any common multiple will work. So what I teach my students is to use the butterfly technique, which is what we're going to work with today. So we're going to start by doing 2/3 plus 1/4. So the reason why I call this the butterfly technique is because I'm going to be bubbling in numbers from across from each other, and it's going to kind of look like butterfly wings. So my goal is to have the same number on the bottom. To be able to do that, I'm going to bubble in the 2 and the 4. I'm going to bubble the 3 and the 1, and then I'm going to connect the 3 and the 4. And anything that I just connected, I'm going to multiply together. Because if I change my denominator, I also have to change my numerator by the same number. So I'm going to multiply both numbers on my right fraction by 3 and both numbers on my left fraction by 4. This will give me the same denominator and my equivalent fractions. So 4 times 2 is 8. I'm going to put my product just above my current numerator. 3 times 1 is 3. 3 times 4 is 12. So now I have all the numbers I need to rewrite my fractions. So 8 over 12. It's an addition problem, so plus 3 over 12. So I have the same fractions, but just in a different form. So 2/3 is equivalent to 8/12. Now, when we add fractions, we only add the numerator, which is the top number. We do not do anything with the denominator. All we're going to do is bring it over because our pieces are not going to be changing sizes. We're just adding more pieces together. So 8 plus 3 is 11. And I'm bringing over my 12. So our solution is 11/12. Now I need to ask myself, can I simplify this? Because we always want our fractions in simplest form unless it tells us otherwise. So we need to ask ourselves, does this have a common factor besides 1? Because every number has the common factor of 1. And 11's prime, which means that it only has factors of 1 and 11. And 12 is not divisible by 11, so that's as far as we can go. So 2/3 plus 1/4 is equal to 11/12. Okay, let's look at another example. And while I'm erasing this, I wanted to pose a question to you guys. Where do you use fractions in real life? What do you think? When would I ever use this? In a career? At home? Just put down your answers in the comments, and I love to see what you guys can come up with. Okay, so our next problem is going to be a subtraction problem. So I'm going to do 7/10 take away 2/5. So we are going to use the exact same method with the butterfly, because when we add or subtract fractions, it's going to be the exact same process. We're just going to subtract our numerators instead of adding them. So I'm going to bubble in the cross numbers. So I'm going to bubble in the 7 and the 5. I'm going to bubble the 2 and the 10. And I'm going to connect the 10 and the 5. Now, anything that we connected, we multiply. 7 times 5 is 35. 10 times 2 is 20. 10 times 5 is 50. Now we have our equivalent fractions. So 35 over 50, it's a subtraction problem, 20 over 50. It's super important that you put them in the same order that they originally were. So the 35 is on the left, so it has to be the numerator on the left. The 20 is on the right, so it has to be my numerator on my right. Otherwise, you're getting a completely different math problem. Okay, so now we bring over our denominator. It does not change, and I subtract my numerator. 35 take away 20 is 15. I need to ask myself, does it have a common factor? This one does. So any number that ends in a 5 or a 0 is divisible by 5. So I'm going to divide 15 and 50 by 5. 15 divided by 5 is 3. 50 divided by 5 is 10. I need to double check, is this divisible by anything? Can I divide 3 and 10 by any common factor? I can't. 3 is prime, so that's as far as we can go. So 7/10 take away 2/5 is 3/10. If you notice, I did not use the least common multiple. I could have just simplified this to 10 on both numbers, but this butterfly method works every time, regardless if you know the least common multiple for the denominators. So if you know it, you can just change one of the fractions to get the same denominator, but my method of the butterfly technique works every single time. You just have to divide at the bottom when you have your answer if you need to simplify. Okay, we're going to do one more example, and it's going to be an addition again. So we are going to be adding, our two numbers are going to be 3/5 and 3/4. I would recommend at this point, if you would like to pause the video and see if you get the same answer after you solve the problem. So it's 3/5 plus 3/4. So if you'd like to pause the video to see if you can figure out the answer and then come back to us, that would be a great idea. Otherwise, I'm going to go ahead and solve the problem. So we're going to cross bubble. I'm going to bubble in my left 3 and my 4. I'm going to bubble in my right 3 and my 5. And I'm going to connect my bases. Anything I've bubbled together, I'm going to multiply. 4 times 3 is 12. 5 times 3 is 15. 5 times 4 is 20. Now I'm going to bring it down so I can solve. 12 over 20. It's an addition problem. Make sure you double check what your sign is and make sure you bring down the correct one. 15 over 20. I add my numerators, keep my denominator. 12 plus 15 is 27. Bring over my 20. Now, if you notice, my numerator is larger than my denominator, which means I have a whole number in there. So my whole is only 20 pieces, and I have 27. So I need to take that whole out. There's two ways that we can do this. We can either divide and get our quotient, or we can repeatedly subtract our denominator from our numerator. This one will probably be easier if we subtract, just because it's very similar numbers. So how many times can I take 20 out of 27? And I can take it out one time. That's going to be my whole number because I have a whole 20 20ths. Now, when I take 20 away from 27, I need to ask myself, what do I have left? So 27, take away 20, it's going to be 7. And then I bring over my denominator. So I have 1 and 7 20ths. 7's prime, and I cannot divide 20 by 7, so I am done. So the answer is 1 and 7 20ths. If you have any questions, please let me know in the comments. If you have any suggestions of videos that you would like to see or any content that you are confused about, I'd love to know so I can reach your needs. And I hope you guys have a great day. Have a good day. Bye.